All right. So yesterday class we were talking about threads, how to do multi-threading, what are the different ways thread can be created. We have seen like extendable threads as well as runnable interface, and also we have seen the thread life cycle. So what is the 5 steps involved in thread life cycle, like new, runnable, running, block, right? So all the states we have seen. So as I said yesterday, today we are going to see about the how to execute these thread programs, or how the thread programs will be executed, right? So let us see one by one. So I'm taking the help of usually we are taking Pisa, but Pisa is not accepting this thread concept. So this is a compiler which I'm using now for this online-java.com. So this is the online compiler which I'm using, online-java.com, where we are going to execute the thread programming. See, as I said yesterday, there are two ways we can execute the thread programming. So the first one is by using extends keyword. By using extends keyword. So for whom we are going to create the extends keyword? So we are going to create extends keyword with the main class. We are going to create a extend keyword with the main class, right? Now you can see here, I'm creating a class called multi. For that, I'm extending the thread class. So that means what is going to happen now? This multi class is going to act as a thread. It is going to act as a thread. So within that, I'm writing the run method. As I said, so as also we have seen, there are so many methods which are available with respect to threads. So we need to make use of those methods when you want to implement that. When you want to implement threads, multi-threading concept or multitasking concept, then we need to use those methods. Now what I'm doing, I'm implementing the run method. So where we use run method, what is the purpose of run method? So when you want to perform particular task, then we are going to use the run method. So I'm mentioning some task. What is the task I'm mentioning? I'm asking to print this statement. I'm asking to print this statement. Now, so this particular portion is going to work as one single thread. This particular portion is going to work as a single thread. Now what I'm going to do, I'm just going to initiate this thread. How to initiate the thread in extendable threads concept? So first what we are going to do, we are going to write the main statement. Then I'm creating an object for the class. So class is multi. I'm creating an object as T1. So if you want to initiate the thread, what is the method we need to use? We need to use start method. We need to use start method. You can see here. So when you want to create a new thread, you need to use start method. So I'm going to use T1.start. T1.start. So the moment when we call the start method, it will go here and it will, who is going to go there? The compiler. Compiler will go here and identifies that, okay, multi is extending the features of a class called thread. Features of a class called thread. Then it will execute the run method. Then it will execute the run method and it will print whatever is there in the run method. Now, if I execute this, so we should get the output as thread is running. So you can see here. You can see here. So how it is happening? Again, I'm explaining for your sake. I'm creating a class called multi. For that, I'm extending the thread class. See, don't get confused. What is thread here? Thread is a predefined class. Thread is a predefined class in the Java. So that thread class properties I'm extending to multi. The thread class properties I'm extending it to multi. So when I extend it, it is going to start the execution. So if you want to do some task in the thread class, what you need to do, you need to call run method. You need to call run method. So once I call the run method, what is going to happen here? The run is going to get executed. So if I want to execute run method, what I need to do? I need to first start the thread. How to start the thread? So using start method. Using start method, right? So this is how we are going to create a thread in the extends concept, that is extendable threads. That is extendable thread, right? Sorry. So any doubt in this, you can ask. Any doubt in this, you can ask now. So it's very simple. I'm creating the class called multi. For that, I'm extending the features of a class called thread. I'm extending the features of a class called thread. Just give me a minute. I'm sorry. I forgot to connect charger, so I just connected. Yeah, you can see here now. So I'm creating a class called multi. For that, I'm extending the thread features using thread. Now in thread, what we need to write? So whatever activity you want to perform, you can write it here in the run method, right? So now in the main function, I'm creating object for this particular class called multi. So my object is T1. So how to initiate the thread? So if you want to initiate the thread, you need to use start method. You need to use start method, that is T1.start. Now what is going to happen? The moment start method has been seen by the compiler, so it will understand that I need to do some activity. Then it will go to the class. Then here it reads extends the thread class. So it understands that, okay, this is a thread class, then it will search for the run method. So in the run method, whatever is there, it will get executed. So in the run method, we have thread is running, which we have written in the system.out.println, that will get printed. So is it clear to everyone? Any doubt? Is it clear or any doubt in this? So this is how extendable threads will be implemented in Java using extends keyword. Extends keyword. Good. So what about others? Is it clear? Any doubt in that? Okay. Fine. Fine. So let us go to the runnable interface. How to create runnable interface? This is one way of creating the threads. Next is runnable interface. Let us just go here. So how to implement runnable? So you need to use implements keyword. You need to use implements keyword, right? So first what I'm doing, I'm creating a class called myThread, right? I'm creating a class called myThread, which is going to implement runnable interface, Within that, again, you need to write the run method only. You cannot change this method. See, you cannot change the methods, that you should remember. These methods, you cannot change it. You can change the logic of implementing the threads. Sorry, you can change the logic of implementing the threads. So if you go here in the particular thread, extendable threads, you can call it as extends. Whereas if you want to go for runnable, you need to use implements runnable interface. Please understand, this is the two interview questions I'm talking about. How will you implement inheritance in Java using extends keyword? How will you implement interfaces in Java using implements keyword? So that's why I'm calling this as a runnable interface. Sorry, I'm calling this as a runnable interface. So that means I'm creating a runnable interface. Within that, I'm writing the run method. Now let us see how we are going to call this class. How we are going to call this class. So I'm creating one main class called myThreadDemo. This is my main class. Please don't get confused. This is not the main class. This is a thread class. This is just a thread class which we are writing. So just to create our own threads, we are writing that. But which is the main thread? So the main thread is going to be myThreadDemo. This is the main thread. So within this, I'm calling the main function. Within this, I'm calling the main function. Then what I'm going to do? I'm going to call the thread. For this thread, I'm creating the object. Please observe very clearly here. Please observe very clearly here. Don't get confused. I'm creating object for the thread class. I'm creating object for the thread class, not for the main class. Because I want to implement runnable interface. I want to implement runnable interface. So when you want to create runnable interface for the threads, you need to create object for the thread class, not for the main class. So the moment I create a object for my thread class, now what I need to do? I need to create a thread for that. How to create a thread? Thread name equals to new thread of this object. So object we are passing as a reference. Object we are passing as a reference. So thread t equals to new thread of empty. What is empty here? Empty is the object which we are passing as a reference. Then as usual, you need to write the start method. As usual, you need to write the start method. So the moment you write the start method, then it will see what is t. Then the compiler will understand that t is nothing but a thread. For whom we are creating this thread? We are creating to an object reference called empty. For whom it empty belongs to? Empty belongs to a thread class called myThread. Then it will go directly to the myThread, the start method, and it will run this particular statement. It will run this particular block, not statement. It will run this particular block, right? So now when we execute this, first we will execute, again I'll explain if required. When I execute this, you can see concurrent thread started running. So this is a statement, right? Now you need to understand very clearly here 2 points. One is we need to create object reference for the thread class. Second one is we need to create a thread, individual thread, where we are going to call or where we are going to pass object as a reference for this thread. Then when we start the thread, so it is going to check which class it belongs to, thread T. And then it is going to see which is the object reference and which class it belongs to. Then it is going to execute that particular class. See, what is the difference between this one and this one? Can any one of you tell me what is the difference between this one and this one? What is the difference between extendable threads, runnable interface? What is the major difference? Both are implementing threads only, but what is the major difference? As per your understanding, what is the major difference? Yes? You can unmute and answer, or you can type in the chat box. What is the major difference between extendable threads and runnable interface? No idea. All right. So I'll tell you, because this is the first time, I know it will be confusing. See, extendable threads, still people are coming. Okay. See, in extendable threads, what is going to happen? We are implementing thread as an extension to the main class. We are implementing thread as a extension to the main class, and for this class object, we are taking as a reference. This class object we are taking as a reference. That means thread is not getting implemented individually. Thread is not getting implemented individually. It is a dependent of main class. Whereas here, thread is independent to main class. Thread is independent to main class. So that means you can create any number of threads individually without depending on the main class. See, this main class I am not touching anywhere, my thread demo. I am working only on my original class which I have created, thread class. Now what is the advantage? What is the advantage? So if you do like this, same thread, if you want to make use in some other program or some other system, then you can make use of it. But here, what is going to happen? This also you can make use, but whatever logic this particular main class is going to get changed, whatever logic is going to be changed here, you should adopt to it. But here it is not the scenario. You can modify this run method according to your need. You can modify run method according to your need, because both of them are independent to each other. Whereas here it is dependent on the main class. Depend on the main class. If someone modifies here saying that T2, someone modifies here T2, then if you execute it, so what is going to happen? We'll see. See, this is a problem, but here not the criteria, because we are creating the object reference for thread class. So if someone modifies here, no problem. So it will get modified everywhere. Say for example, if I am making this one as empty one, obviously this is also belongs to empty one. We are going to make it empty one, and then we are going to call with the thread. So objects are not going to play a vital role here. Objects are not going to play a vital role. You can see here. So that means the threads are working individual to the main class in runnable interface. Then here, whereas in extendable threads, they are depending on the class. See, that is the reason it is called runnable interface. We are creating an interface. We are creating a platform for threads to work individually. Whereas in extendable threads, we are dependent of the class. Is it clear, everyone? Runnable interface and threads, extendable threads. Why we are creating like that? Or do you want me to explain program once again? I want reply from everyone, because we have more than 30 plus students in the class. Only 2-3 members are raising hands. Okay. If someone wants me to explain once again, put in the chat box, I'll explain. Right. So these are the two methods which we are going to use for the extendable and runnable interface. Now, see, as I said in the last class, we need to see so many methods are available, but at least few methods we are going to see which are very important. Now we will see one method called sleep method. See, yesterday I'm showing one function here which is called void sleep. What it will do? It will make thread to suspend for a time duration in milliseconds. In milliseconds, you can see here. Now what I'm doing here is I'm creating a thread class thread name extends the thread class. And within the run method, I'm writing the logic. What is the logic I'm writing? For int I equals to 1, I less than 5, I plus plus. So first I'm making thread to sleep for some time. Let me make 500. I am making thread to sleep for 500 milliseconds. Milliseconds. Within try block I'm writing. In the catch block I'm also writing the error. If something goes wrong, if thread get blocked, then try to push that error. If not, it is going to print the I value. So initially I value is 1. So 2, 3, 4, 5. So like that is going to print the I value. Now what I'm going to do for this test sleep method 1 T1, I'm creating for test sleep method 1, I'm creating an object called T1. For the same method, so for the same class, not method. For the same class, I'm creating one more object called T2. T12 and T1 dot start, T2 dot start. Now it is what is going to do. I'm calling both the threads at a time. Please observe, this is very important concept, not for your VTU exam. See, in VTU somehow you will write sleep method, but it's very important once you become software engineer also. If in your company, if your person, project leader or someone is asking you to write multiple threads to initiate multiple threads at a time. Initiate multiple threads at a time. So how we need to do it? That is very important. Now you can see here I have created two objects T1 and T2 for the same class. I'm going to start the thread with respect to these two objects at a time, T1 dot start, T2 dot start. So now we will see whether it is going to work or not. So what actually it has to happen? So the moment it will see start method, it has to come here. It need to read the I value and it should wait for 500 milliseconds. 500 milliseconds, then it will print the I value. Suppose if there is any error, maybe memory error, hardware failure, then it will throw the exception. That it will throw the exception. It will say what is that exception. E is nothing but the interrupted exception. Why it is got interrupted, whether hardware failure, memory failure, that will be printed. Now when I execute it, when I execute this program, because I started two threads at a time, see, you can see the output. What is happening? First T1 dot started, it went and did some process. Again T2 also going parallelly. So both the threads are running concurrently, one after another, one after other, one after other, one after other. Then it will printing the value. But I have given 500. That's why you couldn't able to see the difference. Now let me give you give this one as 5000. Then you can understand sleep method. So just run it again. Now you can observe the output. Please observe the output. Once output gets started, then you observe it. What is the difference compared to previous? See, it is waiting for 5000 milliseconds. You can see here. First it printed. See again, second output printed. Again wait for 5000 milliseconds. Third, 5000 milliseconds. Fourth, 5000 milliseconds, and it is exited. So this is the main use of the sleep method. So when you want to make one thread to sleep for a while based on the time duration, you can give any how much time you want, you can give, but you should also wait. That is very important. If I give 50,000, let's say for example, I'm just giving 50,000 now. I increase 5,000 to 50,000. Now it will start executing again. You can also understand try and catch block here. This is a default try and catch because we don't know what is the error we are going to get. That's why we are in the catch block. We are telling interrupted exception. It might be anything, memory error, hardware failure, anything. It is going to print. Why we are writing this? There is a possibility because sometimes thread will get struck within 50,000 milliseconds. So you may get error. That's why we are writing try and catch block. Now you can see 50,000 seconds. So first time it came, still it is waiting because before it prints, it's need to wait for 50,000 milliseconds. Okay, so let us take some time for this one. So session killed due to timeout. So you can see here. See, this is called try and catch exception. Why session got killed timeout? Because might be, see, because the various reasons. One thing might be I'm using internet might be slow, this website is not responding. Various reasons it is taking, right? So again, if I run it again, because the compiler might have designed such a way that after some time it might be saying your compiler is idle, so you make it as a kill. So that's why it is printing the raw, the exception. Now you can understand exception handling also, because I have not defined any exception. It is the default exception. If you remember, when we talked about exception handling, we said default exception. Few default exceptions will be catched here and then it will print the output. If it is offline, it will take some time and it will print the output also, because online, so it is getting killed, process getting killed, right? So I'll only stop here. Again, it will get killed because 50,000 is a huge time for the online web browser. So till that time, if it is idle, it feels that nothing is happening. But if I give 5,000 milliseconds, you can see the output will start coming. See here. So this is the main advantage of the sleep method. Is it clear, everyone? What is sleep method? Yes. So one hand raised. Okay, good. Now at least I will be having an idea. Okay, someone is listening that side. Otherwise, if you're not even raising the hand, no, it will be something like teaching to the walls and the boards of the class, right? Okay, thank you so much. So let us come back now. So this is the sleep method. Let us see one more method, which is join method. Now let us go to our PDF. Yes. So where is join? Yeah. So why we use join? You can read it here. Technical definition of join. This method used to queue up a thread in execution. Once called on thread, current thread will wait till calling thread completes its execution. So that means the current running thread will wait till the called thread get executed. So let us go here. Let us understand now. So same way, I am writing one more method, class called test method join method 2 extends thread class. Within this run method only I am writing same logic. I am trying to print the 1 to 5 values with a sleep time of 500. Now what I am doing here is, you can see here, this is the difference. I am creating 3 objects, T1, T2, T3 for the class test join method 2. Test join method 2. Now what I'm doing, initially I'm starting the thread T1. I'm starting the thread T1. So within the try block, what I'm doing, I'm trying to join the T1 for 1500 milliseconds. 1500 milliseconds. After that only I'm going to start T2 and T3. After this, I'm going to start T2 and T3. Now let us first execute, then I'll explain you how it is going to work. See, the moment you execute this, first T1 is going to start the execution. See, 1, 2, 3, it's printed. Okay, let us keep some extra time so that you can understand much more easily. Let me put 5,000 here. Now let us execute. So T1 started the initiation. Yeah, please observe this logic and this output, you can understand. So now T1 started the execution, it is printing the values. See, it is waited for 1500 seconds here because it needs to join with the next thread. So now next thread joined T2, T3. You can see here T2, T3 joined. 3 is printing 3 times, 4 is printing 3 times. So that means T1 stopped the execution, then remaining value started the execution. That 1500 seconds which we mentioned here to join, it is waiting there. It is printing 1, then it is waiting, then it is starting the execution with the other threads. So basically what is going to happen here is, so T1 started the execution. Again, T1 needs to join means T2, T3 started execution. See, the understanding is very simple. Initially T1, T2, T3 has to print. So it started the execution. But next time when iteration came, T1 has to wait for 1500 seconds. Immediately T2, T3 will start the execution. First time what is happening? This is the T1 value. This is the, sorry, 1 second. This is the T1 value. This is the T2 value. This is the T3 value. But second time onwards, this is T2, T3, T1. Why? Because T1 is joined. So that means until T2, T3 completes execution, T1 is not going to do. So when it comes to 3 also, value 3 also, this is the T2 value, T3 value, then T1, T2, T3, T1. So T1 waited for a while. Because until unless T2, T3 completes, T1 is going to join. So it is going to wait for a while, then it will execute the process. Right? So when we use join method, so that is what is going to happen. So that means until unless other through threads get executed, it will wait. Once it executes, third value it will come. Once these two executes, third value it will come. So like this, we can implement the join method or join class, or I won't say join class, it's a join method in threads. So is it clear? First time T1, T2, T3 executed because T1 is getting joined. Next time it will be T2, T3, T1, T2, T3, T1, T2, T3, T1. Only initial state is T1, T2, T3. After that T2, T3, T1. So why it is so? Because we are using the join method. Right? So is it clear?
Sir, initially when we run the program, starting there will be a delay, right? So it's because of sleep or join, sir?
No, it is because of sleep. Delay is because of sleep. Execution is because of join. Okay, see one little concentration here is sleep only will make the delay, not join. Join what it will do? So join will make the thread to join after T2, T3 will get executed. But why we mentioned 1500 there? Because when T1 first time executes and T2, T3 will start the process, it will go to the sleep method, 500 milliseconds or 5000, whatever it is. So it will wait for some time. Then T1 is going to just wait for that 5000 or 500 milliseconds only. Then it will start with the T2, T3. But why join required 1500 milliseconds? After 1500 milliseconds, T1 is going to join the process. That's why T2, T3 will get executed, then T1. Right? It is the parameter. Yeah, 1500 is the parameter. After that many milliseconds, you join. That's what we are telling. Threads are not going to wait. T2, T3 will be keep on executing. T1 will be joining at the end. Okay, is it clear, everyone? So basically, join what it will do is whichever thread you are making to join, remaining threads will get executed, and this thread will join after some time. Whatever stipulated time you will mention. If you don't mention any time, so it will take its own time. After remaining threads completes, then it will join. Now let us see that also what is going to happen. Let me remove this. Value itself. I'm not adding this. Let us see what is the error we will get. So I'm just executing. I'm removing that and then I'm executing. What is the error we will get? We'll see. Right. So what happened? Any one of you, what happened now?
First T1 will be getting executed, then T2 and T3 values will be displayed.
Yes. So first T1 executed entire its execution, which where it printed all the values. We wrote join method, but when we need to join, I have not mentioned. So immediately what happened? Only T2, T3 got executed. So when I mentioned some value, T1 is also going to join along with the remaining threads. Hope now you understood. Now it is clear for everyone. Right? When we want mention the time, it is going to execute individually. It doesn't know when it needs to join. By the time it will join, it will get, the program get executed. I think in computer organization or CN, you will study one concept called deadlocks. You have studied CO already, computer organization?
In operating system, sir.
In operating system also you will study deadlock. So this is how deadlock is going to happen. What will happen? See, T1 will be under assumption that I need to join, but T2, T3 completed the process. T2, T3 completed the process. Till T1 is still waiting for the join. T1 will be keep on waiting. So that means the thread got blocked. This thread got blocked. So this is how your deadlocks will occur. To avoid those deadlocks, you have some methods in your operating system or CO or CN, wherever you study. But in programming, what we are going to do, we are going to mention sometime. Maybe after 1000 milliseconds, after 2000 milliseconds, you join back. You join back so that the execution will continue. Right. So is it clear now? What is join? Still any doubt? Yes. What about others? But see, one of the very interesting topic in Java when you do it, in your hands, if you start writing thread programming, see the way you are going to feel that concept, enjoy that concept is really good. So those who are interested, you can learn it personally apart from the syllabus, whatever is there, you can do it. So these are the few important methods. We'll also see a couple of more methods. So join we have seen now, till join. Yes. So we also have get name, set name, get ID, right? So now you can see here what we are doing. We are just creating a thread. We are extending the thread. We are calling the run method. In the main method, we are creating T1 and T2 as objects. So now I want to get the name of the thread 1, name of the thread 2. What is going to happen, we will see. And also we want to get the ID of T1. Then we are starting T1 and T2. So we set the name as whatever name you want, you can set it. So after changing the name of T1, so we want to get the name. Now what is going to happen? We set some name for that. We will see now. So what is the name of thread 1 here? Thread 0. Name of thread 2 is thread 1. See, thread name is nothing but it will start from thread 0, thread 1, thread 2, thread 3, thread 4 like that. And what is the ID of thread? So this ID of thread will be generated from the compiler. This ID of thread will be generated from the compiler. So compiler will take some name, some ID. Then it started the execution. We set some name for T1. When you print T1.getName again, so it will print whatever name we have given. Whatever name we have given. So this is another 3 methods which we have seen: get name, set name, ID. So that means for a thread, you can also keep your own name. If you want to keep as SVC, you can keep it T1.setName equals to SVC. If you don't keep the name, it will be taken as thread 0, thread 1, thread 2, thread 3, thread 4, thread 5, etc., etc., etc. So depending on the which thread is executing. Is it clear? Set name, get name, and ID. Any doubt in this? Let us also execute this. It's no need to execute, but just for your sake, because already it is executed program only. No? So let me go to my compiler now. It is not opening. Yeah. So let me open this. The class name is join method 3. See, as I suggested already to all of you, please don't waste time in just thinking that I don't have mobile, I don't have laptop. If you have a zeal to learn, you can learn so many things in this era. Only thing is you should have interest to learn the things. So now I executed it. So initially thread value is 0, thread name is 0 and 1. Then we have given some name for that. We have executed. Yeah, you can see now. Yes. So initially the thread name is 0, 1, but their ID is 8, but here it is 10. Here it is 10. So how it is 10? Because depends already how many threads we executed. Based on that, it is taking the name. And you can also have your own name for the thread. Okay, sorry. So you can also have your own name for the thread. You can see here, right? I think it is clear to everyone. So let us go to the next concept. Yeah, so if I want to know which thread is running currently, which thread is currently running. So how to get that? In the run method, thread dot current thread dot get name. See, I have 2 objects created, 2 threads started, T1 and T2. So if I want to know which threads are running parallelly, right? So let us just copy this once again. So let me go here, add on one more program. Just paste it, sorry, just paste it here. I don't know how many of you really like to program, but when you start doing the programming, if you are getting the result, no, if you are getting the result, that is the satisfaction what we will get. So if you are not getting the satisfaction, you should not get no lose or something like should not feel bad. You need to keep on trying. Surely you will get output. See, these are the sample programs. I'm just copying and doing. Surely I'll get output. Some programs you won't get it when you do it on your own. So something
Sir,
went wrong.
starting some like
Okay.
twice you have done.
Okay, fine. Thank you. So let me execute. Still some error is there. What is the error? Public static void main test join method for. Let me just check. This join method correct only. See, copied program also sometimes giving error. No problem. Here. Let us try now. Still errors are there. We'll try to it. Something is not taking. Class or interface or enum expect head. What is the problem? Same error. Class interface enum expected. Already this is there. This program is there. No. Program is correct only. No errors. Same name is there somewhere? No. Test join method 4. Okay, I'll see to it and let you know. No need to waste the time on that. Later, next class, I'll show you. Right, next. Yeah, this already we have seen, getting the name and setting the name. So you can set the name and you can get the name for the threads. And current thread, we are doing it. Some error is coming. We'll see that. Yes, so this is another important thing. We can set the priority for the thread. So when you want to set the priority for the thread, there are three set priorities we can set: minimum priority, normal priority, maximum priority. So the default priority of a thread is 5, which is normal priority. So minimum priority is 1 and maximum priority is 10. So whichever you want to give the thread highest priority, you can go for maximum. If you want to give normal priority, 5. So it is like, okay, normally minimum priority is 1. So how to give priority here? It's very simple. So you create the object. So when you take that object and set the priority, whether you want to give thread the minimum priority or maximum priority or normal priority, then you start with the start method. Then you start with the start method. So which is having maximum priority, then that thread will get printed first. That thread will get printed. See here we have given the minimum priority thread is 1 and maximum priority thread is 2. So when you execute this program, what is the thread it is running? It is just showing here. So the thread name, running thread name is thread dot get name of thread dot current thread dot get name of. So current thread is thread 0. So the priority value it is printing. What is the priority value of that? And then what is the priority value of thread 1? So what is the priority value of thread 1? So that means, see, you can also set the priority. Why we need to set the priority? Because sometimes we want some threads to execute first before other threads. So that time you can set the priority value, maximum thread or minimum thread, normal priority. Then you can start executing the threads. So you have so many methods because as per syllabus, very few important methods they have shown. So we are seeing only those methods. We are not seeing all the methods because if you want to see all the methods, it required at least 5 to 6 classes. Yeah. So this is another method, is alive. You can check whether the thread is alive or not along with the join. So if you come down here, you can see here I'm writing the thread. So this is for the which thread it is. Yes. So you can see here, T1 is thread now. You can check whether it is alive or not. So if it writes output value as true, thread is alive. That means thread is still alive and it is running. If it comes false value, then thread is not alive. So is alive is another method which we'll use for the checking whether thread is alive or not. So join already we have seen. What is join? You can see here. So we have already seen the join method and specifying time with join. So this is what I explained. 1400 we have taken now. So we have seen that. So next is synchronization, thread synchronization. So what is thread synchronization? Why we need to use thread synchronization? We will see in the next class because I don't want you to get confused. Now we have seen how to create the threads, how to use the threads either in the runnable interface or extendable threads. And also we have seen joining the threads. And also we have seen set name, get name, ID values of the threads. And we also seen the sleep method, how to use the sleep method. And in the join, we have seen two methods, one with specifying some time duration without time duration. What is the difference? And one more is alive. So is alive will say whether the thread is alive or not. So if it is alive, it will print the true value. If it is not alive, it will print the false value. So most of the times when we will get false value, if thread get blocked, if thread is not able to execute the process due to some errors, then the is alive value will become false. Is alive value will become false, right? So then we need to see about the thread synchronization. Why we require thread synchronization? Because we will be having so many resources to access. Might be one thread is accessing one resource, no problem. Multiple threads trying to access the same resource. Multiple threads trying to access the same resource. Say as I said yesterday, only one suite counter is there. All the department students are accessing that. Then how we are going to synchronize it? What are the ways we are going to synchronize it? What is the advantage of synchronization? So those things we will see in the next class, right? I'll stop it here, and in the next class we will see what is thread synchronization, how to do the thread synchronization, etc. Yeah, so just 1 second. All right, stopped recording. Stop recording.